Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. The rise of hyperscale data centers has upended computing and network equipment business models over the past several years. The pluggable optics industry is no exception and has definitely been impacted. I'm fortunate enough to have as a guest today someone who has seen that transformation from the inside. This is episode 28, and we conclude our second conversation with Ron Horan. You may remember him from a previous series of this podcast on silicon photonics. In this episode, we talk about future 800 gig and 1.6 terabit optical transceivers. Ron attended the University of Texas at San Antonio for both his bachelor's and master's degrees. His master's thesis topic, entitled Synthetic Vision Landing Aid System, was patented as the first GPS-based aircraft landing aid. From 1994 to 99, while at Compaq, he earned 15 patent awards. In 2001, he joined Broadcom Corporation, where he managed field applications engineering for the compute segment team, ran program management in the networking BU, and was a senior director of sales and strategic account manager covering the Hewlett-Packard worldwide account. In 2011, Ron moved to Luxtera, where he worked as vice president of sales before moving into the role as vice president of marketing. Luxtera was eventually acquired by Cisco in 2019, where Ron now runs product management for the Cisco Client Optics Group. If you haven't already, please subscribe to this podcast on Apple Podcasts. You would follow us now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphen and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Ron Horan.
As even with 800 gig, you end up with OSPD, versus QSFP-DD. But as far as the speeds are concerned, I think that what you're probably going to see is more, that coming back together. So I think companies realize that for many reasons, everything from supply chain to, the fact that, hey, guess what? I'm asking for a custom part now, versus what everybody else is doing. There's many reasons, but I think what's happening is you're going to see a reconsolidation of kind of the optics roadmap. You're going to see a lot of companies moving to, I call it 800 gig, but it's really 800 gig aggregate. So it'd be like 2x400 gig. From going from 200 gig, instead of going from 200 gig to 400 gig, they're going from 200 gig to 2x400 gig. And then you're seeing companies that were doing 400 gig now go to 2x400 gig. So there seems to be a speed consolidation around the 800 gig aggregate that you're seeing. And then the next speed up from that is going to be 1.6 terabit. And I think that with the 1.6 terabit, you're probably going to start seeing form factor consolidation. There's a new MSA that's, it's under development right now called OSP XD that even Cisco is co-chairing that MSA. So you're starting to see, I think people realized that it was just unsustainable. It was hard for somebody like Cisco because instead of having one flavor of something, you had to have two of everything. Or four of everything. And so I think that everybody's kind of come to the realization that this was madness, and it's kind of starting to reconciliate again. That's one of the things I'm seeing.
So when the bifurcation started, was the thinking that each of these hyperscalers was so large on its own that they could essentially call the shots for their own market, basically, right?
That's right.
Suppliers would do it because they themselves, as a singular entity, were big enough that it was worthwhile. But now it looks like people are looking more broadly than that and realizing that industry-wide, there are still advantages of having everyone on board on the same standardized form factor.
That's right. I think there was some of that. Well, there's definitely some of that. And then there was also just the obviousness of the next step, right? it just
what makes it so obvious? Did anything what changed people's minds in this 1.6 terabit?
I really think that I really think it was supply chain, because a good example is there's one big web scale that basically went out and they did their own thing. They defined an optics that nobody else on the planet is using, right?
Okay.
And yeah, they're big, but the problem with that is now you're locked into that supply chain, and instead of being able to take advantage of economies of scale and cost vendors that they're buying from to build that optics, writing the cost curve down using economies of scale no longer work as well. And so, and then if there's a supply chain, if there's an issue, if there's an issue out there with some force majeure event or whatever, COVID, or it becomes more difficult for them to recuperate from that, because their supply base is so small.
So even if the volume is very high, just having another option to go to, another vendor to go to, is highly advantageous, because, like you said, if something happens to that one vendor, you've put all your eggs in that one basket.
Yeah, and I mean the web scales long ago went to supply chain risk mitigation, right? It's where they have multiple vendors doing the same standard product, but if all of those vendors are pulling from the same chip supplier to build that optics, and that chip supplier goes down, you're still down, right? And that
you get a lot of empty modules then,
right? So I think that there's just getting back to the kind of the high levelness of this. I think that you're going to see more consolidation in the industry due to things like that. I mean, companies try to do their own thing. They kind of develop proprietary, they specified proprietary optics. Yeah, people went after that, but from their perspective, it wasn't as optimal as it could be. And like I said before, the number one thing that drives these web scales or their hyperscales or whatever is cost. And so, they're looking for every possible way to get costs down. And obviously they have to have a reliable product that works, right? But but what drives their decision making about the direction they go is costs. And so that's really what I think at the end of the day, that's where this ends up.
So when do you think we're going to see 1.6 terabit?
Well, I think I think that right now, I think that 800 gigabit is 2 by 400 gig is probably going to be a 2023, 2024 technology type of thing for the web scales. I think that, realistically, to get to 1.6 terabit, you need a 200 gig. You need 200 gig electrical, 200 gig optical to be able to do that. So you basically have a 2 by 800 gig will be 8 channels of 200 gig, electrically and optically.
Okay.
If that makes sense to you.
Yeah.
And so I think that there's a lot of work that needs to be done. And I think between now and then, basically it's 100 gig per lambda technology is going to be prevalent over the next probably 4, maybe even 5 years. So my point is, all the products that you're going to see from here to then are going to be based on, like an 800 gig. When you get to 1.6 terabit, now you need 200 gig per lambda. And, some people would argue
per electrical lane.
Yeah. And so some people would argue that you can use 16 by 100 gig or, even optically 16 by 100 gig, but we don't necessarily see it that way. We feel like, going wider with 100 gig per lambda may not necessarily be the right answer. We do support the OSIP XD MSA, but I think where this is probably going to end up is more of a 200 gig per lambda to get to 1.6 terabit. And that's probably in the 2025, 2026 timeframe. So maybe sooner. I think people always say that they want to do it sooner, and it's usually a year or two later than what. Like if you go out in the industry, everybody, made a big deal about 400 gig. 400 gig is going to launch in 2018. Now it's going to launch in 2019, but realistically, 400 gig is still ramping, and
yeah. So there's always a distinction between the actual launch and when like meaningful adoption takes place.
Yeah. I think that, and even amongst the hyperscales, there's definitely timing differences, but you just have to be careful in the industry when somebody says, well, you're going to see 1.6 terabit in 2023. That's probably not going to be accurate. You're probably going to end up seeing it in 2025. Just based on historical what tends to happen. That doesn't mean that I'm right and it won't be 2024, but I'm just saying historically it's usually there's a lot of hype around stuff, and then then reality sets in and it ends up being later than that.
Well, Ron, we can always sit down again in a couple of years and check on that.
Yeah.
That was the fourth and final part of my new conversation with Ron Horan. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics, and leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live. And you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog. No spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. Next time, we'll start a new conversation with a new guest. Until next time.